Okay, so let's continue 3.3, the differentiation rules. So now we're gonna talk about two very practical rules. One is called the product rule, the other is called the quotient rule. Okay, so first look at the product rule. If you have two functions, f of x and g of x, they're both differentiable at the corresponding domain. And if you're trying to figure out the derivative of the product of those two, then the product rule says like this. Okay, so basically is you are doing a alternating. So you take the derivative of the first function and then times the second function, and then plus the first function times the derivative of the second function. Okay, so this is the product rule. Okay, so look at this problem here. We have x cubed plus 2x plus 1 times negative 3x squared plus 9. And then I'm asking, okay, to figure out the derivative of this. Of course, guys, you can, you can distribute this and then write into a single giant polynomial and then using the power rule to handle that. However, in this problem, we're going to use the product rule to handle that. Okay, so this is going to be our f of x first function. This is going to be the second function g of x. So based on the product rule, so the derivative of this part, which is going to give us is 3x squared plus 2, right? The derivative of 1 is 0 times negative 3x squared plus 9. And then plus this part, the first function, x cubed plus 2x plus 1 times the derivative of this piece, which is going to be negative 3 times 2x give us is negative 6x. And that's it. Why? Because derivative of 9 is 0. So we complete this part using the product rule. Of course, you can, doing the distribution, they're going to give you is negative 9x to the power 4 plus 27x squared minus 6x squared plus 18, right? And then minus 6x to the power 4 minus 12x squared minus 6x, okay? And you can put all this together, x to the power 4, x to the power 4, you have negative 15, x to the power 4, 27 minus 6 minus 12, gonna give us is 9x squared, okay, 9x squared. And so we have minus 6 here. We have plus 18 here. So this is the final answer, okay, for this problem. Okay, so that's how do we apply the product rule. Very straightforward. All right. So now let's move on to the second rule, which is called the quotient rule. And the quotient rule, you can see the name is like a quotient format, right? So it describes into this. If you have to take the derivative of a format like this, fx over g of x, and the quotient rule says like this. So this derivative gonna equals g of x, okay, the lower part or the denominator part times the derivative of the top part, okay, minus f of x times the derivative of the lower piece and over g of x squared, okay? And order matters here, guys, okay? You cannot mess up the order, and also the connection sign here is negative. So often I'm gonna give students a way to memorize this. So I like to set the top as the high part of this format and set g of x as the lower part of this format. So here's how to remember this. Low d high minus high d low over low squared, okay? How do we think about this. Low, which is the lower function, g of x, times d high, which is the derivative of the high, minus high, f of x, times the derivative of the lower function, which is g prime, over low square, which is g of x squared. Okay, so it's low d high minus high d low. Okay, so this is how I remember this. And then now let's look at one problem about how do we use that. So it's a quotient format. We're gonna apply the quotient rule. So the denominator part is super easy, which is negative 3x cubed plus 7 squared, right? Low squared. And then the top, low d high, so it's negative 3x cubed plus 7, right? Times d high, the derivative of the high part, which gives us is 4x, okay? And then minus high, 2x squared plus 3, okay, times d low, which gonna give you its negative 9x squared, okay, negative 9x squared, okay. And yeah, so it's low d high minus high d low over low square. Of course, we can simplify a little bit more. They're gonna give us negative x to the power of 4 plus 28x, right? And for here, you have a minus times this times another minus, gonna be a plus. Let's see, 18 x to the power of 4. You have a minus, plus, minus, still gonna become plus as a plus, 27x squared, right? Over negative 3x cubed plus 7 squared. Okay. And we can simplify a little bit more, and that is gonna give us is negative 4x to the power of 4. We write in decreasing order plus 27x squared plus 28x over negative 3x cubed plus 7 then squared. So yeah, this is the derivative of this, okay? So by applying the quotient rule, okay? So two very, very practical rules, quotient rule and product rule. So now, before we talk about the higher order derivatives, I would like to let you know that, guys, those, like some of you might ask, okay, where is the product rule and quotient rule from? Well, the answer is from the limited definition, okay, from the limited definition. So basically, what you do here is you think about this is a group of functions here, and then what we'll do, so basically, I'm not trying to scare you, okay, guys, but I just want to let you know. Okay, so basically, we're gonna evaluate this, and then of course use some techniques, and then there's how do we get this from. Okay, similarly, write the quotient format into a limited concept or limited definition, and then by using some techniques, and then we can derive the quotient rule also. Okay, so that's where is it from. Now let's also talk about a very simple concept, okay, which is called the high order derivative. Okay, let me clean. So this high order derivative. So for example, let's look at this. Suppose fx equals, I don't know, x to the power of so 5, okay? So the first derivative, when we take it, we're gonna have it's 5 times x to the power of 4 based on the power law, okay? And we can continue this, guys. You know, if I take the derivative of the first derivative, because this is also a function, then here I'm gonna have the second derivative, which is gonna be 5 times 4 times x cubed, okay? And so this is the second derivative, meaning taking the derivative twice, okay? First derivative and then second. And then of course you can have a third derivative, which is gonna give us 5 times 4 because those are constant times 3 times x squared, right? This is the third derivative. And again, guys, first derivative 1 prime, 2 prime, 3 prime. And then starting from the fourth derivative, some of you might see, wow, what about if we take the 10th derivative? Am I put 10 prime there? Of course not, right? So it's gonna take you a while. Well, starting from the fourth derivative, this is how we write, okay? We write as f on the upper right of f, there is a parenthesis, put a 4, okay? And then that's gonna give us, as you can see, it's a 5 times 4 times 3 times 2x, right? And then the fifth derivative of x, which, do you see that, guys? It's a 5 times 4 times 3 times 2 times 1, right? Because the derivative of x equals 1. What about the sixth derivative of x? Do you see it's a 0 because it's part of the constant? What about seventh derivative? Do you see it's also 0? Right? As long as n is greater or equal than 6, the nth derivative is also 0. Well, why is that, guys? Well, the answer is from the power law. As you remember, when we talk about the power law, it says like this, right? So the derivative of x to the power k is k times x to the power k minus 1. So every time when you take the derivative of x to the power of k, and then actually the order it decreases 1, right? So as you can expect, by applying the fifth order, so you're gonna become into x to the power 0, meaning there is no variable x involved. Instead, after you take the fifth derivative in this problem, you're gonna definitely have a constant, okay? And then starting from the sixth derivative and so on, all the derivative will be 0 because the fifth derivative already a constant. So this is pretty much everything from 3.3, the differentiation rules. And you know, starting from now, you know, we're gonna starting to use these and then play a lot of fun things. Okay, so I'll stop here and I'll see you in the next class.